Welcome to my channel Chemistry Classes. We are discussing chapter Organic Chemistry, some basic principles and techniques, in which we are going to start this topic. This is classification of organic compound, right? First question is, what is organic compounds? Organic compounds are chemical compounds that contain carbon atoms covalently bonded to hydrogen atom along with other atoms such as oxygen, nitrogen, sulfur and halogen, right? So carbon's unique ability to form strong covalent bond with itself and other elements allows the vast diversity of organic compounds. Organic compounds are further divided, as you can see in this picture, right? So first of all, organic compounds is divided into two, that is acyclic and cyclic compounds, right? Acyclic compounds are also known as open chain compounds, and cyclic compounds are also known as closed chain compounds, right? So open chain compounds, we are discussing acyclic compounds or open chain compound, right? So open chain compounds are organic molecule with a linear or branch structure that do not contain any closed loops or ring, right? So they are the open chain, or we called it acyclic compounds. For example, we can take one example of ethane, right? This is open chain. And we can also take one example of branch, that is isobutane, right? So this is the open chain compounds. Next is closed chain compounds, or we call it ring compounds or cyclic compounds, right? So closed chain compounds are those where atoms, commonly carbon, form a closed ring creating a cyclic structure. They create a structure that are cyclic in nature, right? So we can include like aromatic compounds and different compounds. You can see the cyclic or chain compounds. We said that cyclic compounds or closed chain compounds have one or more rings of atom as a part of their structure. So this chain, open chain, closed chain compounds are further divided into aromatic and acyclic compounds, right? So first of all, discuss what is alicyclic compounds, right? So these are cyclic organic compounds that do not possesses the special stability and electronic configuration of aromatic compounds, right? And aromatic compounds are those compounds that are cyclic compounds with a conjugated system of pi electron that result in unique stability and reactivity. We can take example of benzene, right? So in alicyclic compounds, as we said, that contains carbon atom joined in the form of ring is called aliphatic. We also call this aliphatic cyclic, right? So we can take example of these compounds is like cyclopropane in alicyclic, because they are closed, they comes under closed chain compounds. So they are closed chain is further divided into two, that is alicyclic and aromatic. In alicyclic, where I will give you one example, that is cyclopropane, and next example is cyclohexane. These compounds come under alicyclic compounds. Next is aromatic compound. Aromatic compounds from its name, they are cyclic, planar molecule with a ring of conjugated pi electrons, and they follow Huckel's rule, leading to expectation stability. Aromatic compounds follow the Huckel's rule. Huckel rule is what? 4n plus 2. This is the Huckel rule. Basic important example of aromatic compounds is benzene. C6H6. Benzene have conjugated pi electron, as you can see. Right? Aniline is one of their example. Naphthalene is also an example of aromatic compound. As you can see in this structure, aromatic compounds are further divided into three. That is a heterocyclic aromatic compound, non-benzoate compounds, benzoate compounds, right? And alicyclic is further divided into heterocyclic or homocyclic, right? So first we discuss alicyclic compound. In alicyclic, they are further divided into two, that is heterocyclic and homocyclic. Heterocyclic compound is a cyclic structure that has an atom of at least two different elements, like with at least one being an heteroatom, such as nitrogen, oxygen, sulfur in its ring. So heterocyclic compounds are cyclic organic compound in which the ring contain at least one atom other than carbon, that is known as a heteroatom. Heteroatom from its name is showing the atom other than carbon. One different atom is also attached in this compound, right? So we can take example of furane, pyridine, indole. They all are the examples of the heterocyclic compounds that comes under alicyclic compounds. Like I will give one example of furane, that is this structure is this and this, right? So next is a homocyclic. Homocyclic compounds are also known as carbocyclic compound, right? So homocyclic or carbocyclic compounds, these are the carbocyclic rings that do not have aromatic character, as they come under alicyclic, and that's so they are not showing any aromatic character. Their properties are similar to aliphatic compound. Example is cyclopentane, cyclohexane, cyclobutane. All are saturated and unsaturated, right? So these are the homocyclic aromatic compounds. And we have example of this is like cyclohexane. This is the structure of cyclohexane. Next is aromatic compounds is divided into three. One is benzenoid, second is non-benzenoid, and third is heterocyclic aromatic compounds, right? So benzenoids and non-benzenoids, right? I will show you here. Benzenoid compounds are aromatic organic compound that contains one or more benzene ring in their structure. So the benzene ring is a 6-carbon planar cyclic structure with conjugated pi electrons, and that follow the Huckel's rule, giving the molecule special stability due to resonance. So example is benzene. As you can see in benzenoid, their example is benzene, and toluene, naphthalene. Naphthalene contains two fused benzene ring, etc. Right? In non-benzenoid, what happen? In non-benzenoid compounds are aromatic compound. They are aromatic compound, but they do not contain a benzene ring. They don't have any benzene ring. Despite lacking benzene rings, they still display aromaticity due to conjugated cyclic electron system that satisfy the Huckel's rule. Examples is furane, pyrrole. These are the examples of non-benzoate compounds, right? I will give you one example, and that is tropone. Tropone structure is like this. Like this is the example of non-benzoate aromatic compound. And last and the third one of aromatic compound is heterocyclic aromatic compound. Heterocyclic aromatic compounds are the cyclic organic compound in which the ring contain at least one heteroatom, such as nitrogen, oxygen, sulfur, and compound exhibit aromaticity. Aromaticity means what? That compound must have planar, they are cyclic, they are conjugated system, and that follow the Huckel's rule. The ring is cyclic, planar, allowing for continuous overlap of p orbitals and delocalization of a pi orbital, right? So example is furane, pyridine, pyrrole, all are the example of the heterocyclic aromatic compound. So in this video we have discussed organic compounds, and organic compounds are further divided into acyclic or cyclic compound. Then cyclic compounds is further divided into aromatic compounds and alicyclic compound. Aromatic compounds are further divided into three categories, that is heterocyclic, non-benzoate, and benzoate. And alicyclic compounds are divided into heterocyclic and homocyclic. That's all about the classification of organic compounds.